All right, guys, we're going to knock out the geometry mid-year test review study guide exam review. It's got a whole bunch of stuff on here. Some of it hopefully seems pretty obvious, seems pretty comfortable. Some of it might be a total blast from the past. Let's just get into it. Geometry basics. We're talking about points, lines, planes. Remember, points are just capital letters. A line needs to be 2 capital letters. And a plane needs to be 3 capital letters. But a plane could also be 1 lowercase. If you see here, kind of a, or wait, 1 capital letter. There we go. And then this lowercase is for a line. That's right, I had that backwards. Number 1, name a point collinear to points S and T. So I find S and T. These need to be collinear, which means they're in the same line. Which point would you say is collinear? R. There we go. Nice job. We're working with 100% on that exam. We're killing it. Remember, A doesn't count. A is the line. Line A. That doesn't count as a point. That only counts as a line. Give another name for line B. So here's my lowercase line B. I can see that line B is working with these 3 points, V, S, and W. What do you want to call line B? Sure, you could call it VW. That works great. And remember, we want to put a line on top with some arrows because that means it's a line. But there are other things you could call it. You could call it VS, SV, WV, WS, SW. There's a whole bunch of different options that you could call it. It's got to have 2 letters. It's got to have that line on top. Name a point non-coplanar to RTU. RTU. These 3, RTU, are all coplanar. They're all on the same plane. In fact, it's plane P. We need a point that is not coplanar with those 3. 2 options here. What do you think? Yep, W works. Or, there's one more, V works. Now, those are points, and you might see it listed where they actually write the word point W or point V, but you should mostly be good with just a W or just a V. Keeping it going. It's a long review. Let's keep it going. Let's not waste too much time. Up next, we've got a really crazy looking shape. I remember doing this exact picture throughout the year. Name the intersection of planes JKL and HGL. I noticed that L is repeated here. So H, that's the first one. JKL, JKL, JKL is these 3. And so that looks like it's talking about that back wall, right? When I see this shape, I think that is the back side of the barn or something. I'm not sure. Then we have HGL and HGL. This is going to be the bottom of the barn. And so when it says name the intersection, where does this back wall touch the bottom floor? They touch at this line ML. And we can do a line on top. And you know what? We're probably good to just leave it without the arrows, or we could put the arrows. I think either one would be fine. We get the idea either way. 2 planes intersect at a line. That was something that we had to learn before. So 2 planes intersect at a line. Name a point coplanar. It's a lot like the one we just did with letter C up here. Name a point coplanar to F, K, and J. F, K, and J are these 3. Anybody want to name a point? Somebody phoning a friend trying to figure out a point on coplanar. Anybody know a point that's coplanar? Surely somebody can. We good? Shania's? Is it Jazzy's? Is it? No, it's more over here. All right. It's going straight to voicemail. It's very important. We're going with point E. Point E, please, guys. This is the exam review. Hardly anything more important than this all year. Our EJG coplanar, what do you think? We've got EJG. Would you consider those to be coplanar? I don't think so, right? There might be some people who say, oh, well, any 3 points are technically coplanar. They don't look like they're coplanar to me, right? We've got these and G, and they're not sharing any particular plane here, right? When I look at the picture, they're not sharing a plane. So we're just going with no. Different planes. Then we're getting to the distance and midpoint formula. Again, it's been a long time. Lowercase d for distance, square root, parentheses, what we got? X minus x, y minus, oh, why'd I write that? Y, there we go. Speaking and writing at the same time. X minus x, y minus y. Now, funnily enough, this distance formula, which looks like a totally random, jumbled mess of letters, is actually the Pythagorean theorem. Okay? This is your x change. This is your y change. And so you've got your x squared plus y squared equals d, which is the diagonal distance, squared. And the reason that this d is not squared is because we square rooted both sides. Anyways, distance formula, it's literally just the Pythagorean theorem. Midpoint formula is the midpoint. Add them up, divide by 2, right? You might see it kind of written like this. Sum divided by 2. X plus x divided by 2, y plus y divided by 2. We're given these two coordinates here. They're a little bit in a weird spot, so make sure that you know where they're at. And then we've got 4 questions that are all talking about it, or maybe just these first 2 are. Find the length. That's going to be distance. Square root squared. When we learn this, I like to set myself up like this. Particularly, I like to put the minuses in there first, because a lot of times students forget those minuses once they start putting in especially negative numbers. Okay, for this first one, we've got the x's, and for the second one, we've got the y's. Or you could do the y's in the first parentheses and the x in the second. It doesn't matter. And I'll use a as my first one. So I'll do -1, that's my x from a, and I'll do 7, that's my y from a. So a went first, and now b, 11 goes second, -1 goes second. And so in particular, this part right here is why I like to write that negative down ahead of time, because we end up with 7 minus 1, because the 1 minus is from the formula and the other minus is from the coordinate. Then we go to Desmos. We type it in, and we don't always expect a nice number. Sometimes we get a decimal. D equals SQRT, parentheses minus parentheses squared plus parentheses minus parentheses squared. Then let's put those numbers in. -1 and 11. Over here we had 7 and -1. When I type all that in, I got 14.5 4. Let's just go with 1 decimal. D equals 14.4. Good enough. That's just a formula. We're moving on. We're keeping things going. Find the midpoint. Well, the midpoint is going to look like a coordinate. Add them up, divide by 2, right? Find the middle. So I'm going to do -1 plus 11 divided by 2. That's the x and the x. Then I'm going to work with the y's. 7 plus -1 divided by 2. Add them up, cut them in half. So my answer is going to be a coordinate in the middle of these two coordinates. And I can do this in my head. -1 plus 11, that's 10. Cut it in half. That's 5. 7 plus -1, that's 6. Cut it in half. That's 3. Sometimes your midpoint does have fractions / decimal coordinates. It can happen. Keeping it moving, keeping it moving. This segment has a midpoint and an endpoint. So for this one, we're working with a line. Honestly, we were horrible at this when we learned it in the beginning of the year. The midpoint is 2, -7, and the endpoint is 8, -5. What are the coordinates of the other endpoint? We can't just do the midpoint formula in a normal way because the midpoint formula would tell us the middle of these two coordinates. We don't want the middle of these two coordinates. We want to reach all the way out here and figure this out. Okay? There are a couple different ways that you can figure this out. I kind of like to use the formula way. Ms. Bass uses a different way to find this. Do you remember that formula that you used, Ms. Bass?
Oh, SAD?
Yeah.
Stack, add, divide.
SAD. Stack it, add it, divide it. So if we're going to work, let's work with the x coordinate, Ms. Bass. So we would stack it. What are we stacking with the 8 and the 2?
Just write the coordinates like 2, -7.
Mm-hmm.
And then underneath write plus 8, -5.
Okay.
Do it like that. And just add both sides. So you have your 10, -12.
And then just cut them in half or divide them by 2. Sweet. And you're just choosing 2 because you're always divided by 2? Or is...
No, you got to stack. You got to divide by 2.
Right. Sweet. 5 and -6. Oh, I got you. I confused you, Miss Bass. So that is a way to stack, add, divide to find the midpoint. This question is trying to find the endpoint instead of the midpoint. And this 5, -6 is the midpoint here. Not quite. If I did it right, what you were saying.
No, the midpoint is 2, -7. You're looking for the other endpoint.
Right.
They gave you the midpoint already.
Exactly.
So use your midpoint and your other endpoint to find the missing endpoint.
Right.
You just did it.
This one, but this isn't it though.
It's not.
No, because look, 2 and 8 in the middle of 2 and 8 is 5. In between -7, -5 is -6. I think stack, add, divide is just a good way to find a normal midpoint. I don't know, I definitely threw you under the bus. Here's how we're going to solve this question, all right? We're going to make our typical formula, which is sum them up, divide by 2 equals the midpoint. And when we do this, we're just going to have to be careful because midpoint is some of the information that we know. So we're going to do x plus x divided by 2 equals the midpoint. And we know that the midpoint is 2 comma negative 7. So if we're working with the x's, this 2 is the midpoint. Then over here, we're going to have the 8 plus x. That's our mystery x that we don't know. And now we're going to solve for it. We're going to try to solve for this x, so we're going to do times 2 on both sides. We're going to have 8 plus x equals 4. And then we're going to subtract 8 from both sides. All right. I'll help you out when we do the second one. This is the way we did it when we first learned it. And honestly, I don't know if I didn't teach it right or what, but we just weren't very good at it. There was a second way to do it, and I forgot how to do it the second way. So we'll just do it this original way. So our formula is y plus y divided by 2 equals the midpoint. You cool with that?
Why is not x plus x?
Well, we already figured out the x was negative. We're just moving on to the y now. Okay. So the x is the same exact formula. Like, look. So okay, let's do the x first. The x formula is x plus x divided by 2 equals the midpoint. Okay. Normal questions, we would know the x and we would know the x, but we wouldn't know the midpoint, right? That's a normal question. I would say, help me find the midpoint. But for this question, is different. We actually know the midpoint and we're missing an x number. Dre, take one of these, man. And so when we plug things in this time, we actually know what the x number is, but we don't know what the other x number is. And we do know what the midpoint is. So that's why I put the 8 here, because that's our x value of the n. But I don't know the x value that we're looking for. And I do know the midpoint, the 2 and the 2. So let's set that up for the y. Y plus y equals mid, okay? We know the middle y value. What's the y value of the midpoint? Negative 7, right? Fraction 2. Then on top, we only know one of these endpoints, right? We know that this endpoint is negative 5. But I don't know the other one, so that's why I leave my y there. It's coming back to me, Miss Bass. It was something like double it and then subtract it.
Circle the midpoint, double.
Something like that, yeah.
Circle the midpoint, double the midpoint, subtract the endpoint.
Yeah, there it is. I knew it was something like that. Sorry, Miss Bass. So same thing. We're gonna basically double it. And when we double it, we're gonna have negative 5 plus y equals negative 14. That way we get rid of the 2 on the bottom. And then we just move this piece to the other side. Plus 5, y equals negative 9. If you just think of it as a formula where you're plugging in numbers, you just have to be a tiny bit careful because the middle number is actually the one that we do have. That's why the 7 has to go here. This endpoint is the one we actually don't have. Okay, let's just keep it going. If x is the midpoint of line WY and WX and this and all that, what is XY? So let's make a list here, or a diagram here. X is the midpoint, okay. WY, okay, WY. Wx is 3x minus 1. 3x minus 1. And Wy equals, that's the whole thing, 10x minus 26. Find x, y. So we want to make a little equation here that will help us find this missing piece. And we know that half of it is 3x minus 1. If we can figure out what the xy is, we know that these are going to be the same length because x is considered the midpoint. So we basically just need to find either one of these, wx or xy, and we want to make some kind of equation. So let's start with an equal sign. We know a couple things are equal to each other. We know that wx is equal to xy, but we can't really make an equation like that because we don't know what xy is, and it's not really a good way to do that. We also know that if we add up these two things, wx plus xy, it's going to give us this whole piece here. So our equation is going to be, this was called the segment addition postulate, that 10x minus 26, that's the full piece, is equal to 3x minus 1, that's half of it, plus the other half, which is the same thing, because the two halves should be equal. 3x minus 1. So we've got the full piece is equal to half of it plus half of it. And in this class, we've been lucky enough to use Desmos. Let's start to pick up some speed again. We got slowed down by that midpoint question. 10x minus 26 equals 3x minus 1 plus 3x minus 1. Look for it on Desmos. Let me zoom out here. Let me hit the home button here. Looks like a nice 6. Now, 6 is a part of what we want. X equals 6, but the true question says x, y, and we're looking for x, y. X, y. Right, it is 3x minus 1. And we know that the 6 can go into the 3x minus 1. 6 times 3 is 18, minus 1, 17, right? You can use Desmos. We've got 3 times 6 minus 1 is 17. So once we found the 6, we just put the 6 in there, and we got it. This is back to using a little bit of that algebra stuff. That was our first question. It'll probably start coming back more and more as we keep going. Number 7, find the value of x. There's these two questions, there's these two angles, and I'm noticing that these two angles are vertical angles. So what do we know about these two angles? They are congruent. They are equal to each other. And so we just put a nice little equal sign in the middle there. We go to Desmos and we type this in. Again, trying to start picking our speed up a little bit. 12x minus 18 equals 5x plus 59. Make sure you type everything in correctly. Look on Desmos. Might have to zoom out a little bit. I'm seeing 11 as the answer. X equals 11. And for this question, does it want the x or does it want the angle? It says tell me the value of x. So that's it. We don't need to find the actual measure. All right, 8. It says measure of angle LNK. LNK, that's this one right here, is 5x minus 27. And KNM, KNM is KNM, this one right here, 10x minus 3. Mr. Collier, A1. She's not here. I haven't seen her. Yep. Bye. And it says find J and M. Well, J and M is this piece. All right, so we've got three kind of different pieces here. We do know what the L and K is and what the K and M is. With these two pieces, they're going to add up together to make a very specific number. 5x minus 27 can add together with 10x minus 3. And what is that going to be equal to? These two angles, which are supplementary angles, not vertical angles, but supplementary angles, are going to be equal to 180 when you add them together. Again, pick up speed a little bit, use the Desmos. 5x minus 27 plus 10x minus 3 is equal to 180. Desmos says 14. Sounds great. X equals 14. Does this question want the x or does it want the angle? It wants the measure of J and M. J and M is this piece, which is vertical from the L and K piece. So let's use the L and K piece. Once we figure that out, J and M should be the same. All right, the L and K piece is 5x minus 27. Desmos time. 5 times 14 minus 27. 43. Measure of angle J and M equals 43. All right, we're going. We're off that first page. It was a little slow. Now we're talking about multiple angles all working together. We're looking for complementary, supplementary, 90-degree angles. Find each missing measure. We know that this right angle is going to be 90. That's not one of the things that we need. But we do know some other things. We know that, for example, our big angle here, 148, combined with this smaller angle Z, should add up 148 plus Z is equal to 180. Those are supplementary angles combining together to make 180. So on Desmos, we can't really use Z, so I'll just use X. 148 plus Z equals 180. It looks like 32. So Z is going to be a nice little 32 here. What do you want to do next? All right, I helped you out with Z. Anybody got any ideas for X or Y? I agree with you. I think that X is looking pretty vertical here with the Z. So X is going with 32. Nice job. I like the vocab going with vertical. And when it comes to this Y, a couple different ways that we can go about this. If this is a right angle, then I think that this over here should also be a right angle. And that means that all of this is going to add together to make 90 because it's a right angle. Which means that Y plus 32 should make 90. That's called complementary angles. So let's try it out. Y plus 32 equals 90. And zoom out a little bit. I see it there, 58. I think that Y is going to be 58. They gave us a nice short question, PQR. PQR is bisected by QS. Bisects means that it gets cut in half, which means that these two should be equal to each other because the two halves should be equal to each other. It says find the measure of PQR. If we get the top PQS and the bottom SQR, and we get the two different things here, these should be equal to each other. So we're able to go 4x minus 25 needs to be equal to 2x plus 7. And luckily we can use Desmos, speeding it up. 4x minus 25 equals 2x plus 7. Desmos says 16. X equals 16. But that's not exactly what it wants. It wants to find the measure of PQR. That's the whole thing. Which means, and technically these should be the same. So if we find one of them, we can double it. Or we can find both of them and add them together. They should be the same thing. So I'm going to go with this bottom one. It looks kind of easier to me. 2 times 16 plus 7. Isn't that hard to do in my head, but let's just do it. 2 times 16 plus 7 is 39. But 39 is only half of it. So double that 39 and you get 78 degrees. Welcome back. Go, go, go. We're cruising. 11. Angle R and S are complementary. Complementary means they make 90. There you go. Angle, let's call this one R, which is 6x minus 47, and S, which is x plus 4. Find the measure of angle. Okay, we know that they're complementary, which means we know that they add together to make 90. We can use Desmos. 6x minus 47 equals x, nope, plus x plus 4 equals 90. Add them up to make 90. 19. X equals 19. And that's not what they want. They want the measure of angle S. So we do 19 plus 4, which is 23. 23 degrees for the measure of angle S. One last question here, working with these angles. Then we're going to get a big change into the logic statement stuff. Angle C and angle D are supplementary angles. C and D. That means they're going to add up to make 180. Oh, here we go. We get a nice little word problem question. Yuck. Angle D is 9 less than twice angle C. Whew. They try to hit us with a hard one here at the end here. So they don't tell us much about angle C. I'm just going to call angle C a plain old X. And D should be 9 less than twice that. So I'm going to go with twice that minus 9. We know that these are going to add up to make 180. So we add them up, we make 180. Figure out what we got. X plus 2x minus 9 equals 180. And we got 63. X equals 63, which isn't quite what we want. We want the measure of angle D, which is 2 times 63 minus 9, which is 126 minus 9, which is 117. 2 times 63 minus 9, 117. Measure of angle D equals 117. That's what we want. All right. What we just did is grind through like the first month of the class, which had some distance formula, some midpoint formula, which had a lot of the angle addition postulate, segment addition postulate, and at the end of the day, it's just a lot of make these little equations. Do they add up to make 180? Do they add up to be equal to each other? Do they add up to make 90? Just, you gotta find that little equation. Are they supposed to be equal? Are they said to be congruent? Up next is logic. We don't have long till lunch. We'll be pausing this video in just a second. Let's try to crush through logic, because logic isn't necessarily where we want to be for fun. Okay? You got conjunction and disjunction. And if you don't quite remember these, a conjunction is only true when both statements are true, right? That would be like the word and, because they both have to be true. So P and Q, which is this symbol with no A in the middle there. It's supposed to actually look more like that. Then we have disjunction. Obviously, that's going to be the other one, which has the big V in the middle of them. That's true if just one of them is true. Dallas, you get a little shout out in these questions here. We get some statements, PQR. Let's see if we can verify if these are true or false. Is Dallas in Texas?
No.
You swear? Yes, it is. Yes, it is. Dallas is in Texas, at least for now. I heard they might move it over to Tennessee, but for now, it's going to stay in Texas. All birds can fly. That's false, right? I'm thinking about an ostrich, a kiwi, a penguin. A kiwi. A kiwi bird. You ever heard of a kiwi bird? It does kind of look like a coconut with a beak on it. And the last one, complementary angles are always congruent. I think that's going to be false. Complementary means they add up to make 90. Congruent means they're the same. 30 plus 60, that makes 90, and they're different. So I think that that's a false statement. Okay, and now we can even label on here P is true and R is false. With the or statement, only one of them has to be true. Do you think that A, total, is going to be a true or false statement? It's going to be a true statement, right? This V symbol means that one of them has to be true. And luckily for us, P is a true statement. R is not. B is below that. P is a true statement. Q is a false statement. And this A is an and. And that and means that both have to be true. Are both of these true? That's going to be a false statement. Then we got these squiggly lines. These squiggly lines, you remember what those mean?
No.
Not. Or basically the opposite. So if P is true, what is not P? False. And Q? False. This V is an or, which means only one has to be true. We don't have any truths. We are working with false. At the bottom here, we have not Q. That's true. And we have not R. That's true. And this and symbol means that both have to be true, which we do have. All right, then we have the conditional statements. Might be a little tough for us to remember these. If P, then Q, and it comes with an arrow from P to Q. There's inverse, converse, contrapositive. Anybody remember any of these? Q to P, which is the backwards, is that inverse or is that converse? I agree with you. Q to P is converse.
P and Q, they can switch the swing line.
This one?
Yeah.
So what's the first symbol I need? The P, the arrow, then the.
It's not swing. It's swing though.
Then this one,
Yeah.
then the Q.
Yeah. And then the swing with the P too.
I think it needs to be like this.
Yeah, that's what I said.
I got you. Honestly, you guys are both saying squiggly P, squiggly Q. I didn't know what was going on. And lastly, the contrapositive is the inverse and the converse at the same time. It's the squiggly P, squiggly Q, but they're also switched. I'm getting nervous with my inverse statement. Let me double check that. Never hurts to check. Inverse logic statement conditional. Come on, Google, do it for me. So right, that should be right? Not P equals not Q. All right, we're good. Everybody gets a little nervous when they go through that. All right, we got 2 minutes till lunch. Here's what we got at the top here. I'm gonna try to go. I'm done with this. I'm sick of this. Conditional. You just write if, then, and you write the two things, right? 2 angles are adjacent, then they form linear pair. Well, if they're adjacent, they got to be next to each other. They form a linear pair. Linear pair specifically means they have to make 180. I don't think that this works. These two are adjacent. They don't make a linear pair. I'm going false. The inverse. You still put your if. You still put your then. But then you got to do the inverse, meaning you got to put those squiggly lines on there. You say, if 2 angles are not, because now we're doing inverse, adjacent, then they do not form linear pair. Now, even though this original one was false, this one's sounding pretty good. If they're not adjacent, then they are not gonna make a linear pair, right? You have to look like this to make a linear pair. You have to be adjacent. And so I think that this is a true statement. If you are not adjacent, then you ruined it. You are not a linear pair. Converse means switch them up. If they are a linear pair, then they are adjacent. I think this looks pretty good. If you are a linear pair, then you are adjacent. Contrapositive. All right, lunchtime. Have a good lunch. Concentrate. If you are not a linear pair, you are not adjacent.
It's good for. It's better support. No, I thought.